Welcome to Tunneling Today with UCA. This is the podcast where we dig deep into the technical and personal stories of professionals driving progress, one tunnel at a time. Whether you're in the field or somewhere underground, this is where we shine a light on what's happening below our feet. You're listening to part 2 of our inaugural episode. Part 1 features a discussion with Professor Youssef Hashash.
I saw online there was about 300 articles that you've been a part of, and you have 4 patents, and obviously the creation of deep soil. So you want to talk about some of your patents and deep soil and how that's been kind of influential for you. I know that's a big aspect of your creation.
So when I first joined Illinois, I started working on a paper which turned out to be quite influential on seismic design and analysis of underground structures. It's used extensively now in industry for seismic design. So that was a wonderful thing to kind of kick off my career with.
Yeah.
It's 2001.
Okay. Stuff you learned from your consulting time and being on the West Coast.
And then as I started doing some research, so that was a really a milestone in that, in seeing, okay, I can develop things that can be useful to the community. At the same time, I became part of the Mid-America Earthquake Center, and we were studying the issues of how soils change ground motion. So still related to seismic design, right?
Yes,
For tunnels, but this is in the ground. And as I was looking into that problem, I noticed that there were a number of issues that we were not doing it to the best of our abilities. So we started a series of developments, and we wrote our own software because we needed to do our research.
Yeah.
And then people started asking me, Youssef, can we use the program? It's like, okay,
Yes,
please.
Yes.
And then
Starts with one, right?
it always starts with one. And then someone suggested, why don't you add a user interface? We added a user interface. Well, why don't you make it available? Started that. And then now we're, I think, at version 7 of our software.
Yeah.
We've had over the years like 30,000 downloads.
Oh my God.
And just around that number. And it's took off and is being used extensively
Around the globe, right?
Around the globe.
Yeah.
And the advantage of it is we combined in a unique way, in the same sort of analysis framework, both the ability to do nonlinear site response for strong ground motions, as well as equivalent linear, which is more suitable for the weaker levels of shaking than you. And we streamlined the process so that we would hide the complexity away from the user. So allow the users to focus on what they know well, which is engineering.
Exactly.
And so that was very, very important for us as we've done that. And it just took off. And it's used in instruction, in research, and in engineering practice.
Yeah. I mean, that's a good part of the future of tunneling, that this will be used many years in the future with different versions, continuing on.
It is being used.
Exactly.
And continue to be used.
Yes. So let's talk about some of the other accomplishments. So I wanted to talk about the Presidential Early Career Engineer that you got to visit the White House, correct?
Yes. So that's the PCASE Award, the Presidential Early Career Award for Engineers and Scientists, or Scientists and Engineers.
Yeah.
And so it's a selection process across many federal agencies that fund young faculty members. And at the time, I proposed a project on, this was early days of 3D visualization, to visualize material constitutive models, these very, very complex material models, because soil behavior, rock behavior is quite complex. And it's inaccessible to the students if you just show the mathematical formulation. So they're able to more visually and gain recognition. I'm very grateful for the program director at the time was Dr. Priscilla Nelson, who also done tunneling as well.
Yeah.
And it was a treat for someone like me. Went with my wife. We went to the White House and took pictures there and received a nice recognition certificate signed by the president. So it was a really nice way to start my career at the time.
Yeah.
And it was just phenomenal. It encouraged me to continue to think outside the box. And sort of shortly after that, so, when you see these, as I mentioned to you, Illinois has a lot of talented faculty members. So one faculty member, his name is Professor Jamshid Gabusi, he's now retired, was talking to me about this thing called artificial neural networks.
Interesting.
So that's in the early 2000s, okay?
Yes.
That's when artificial intelligence, people
were fuzzy,
and then people were less enthusiastic about it.
Yeah.
And then he described to me how he has been using it to represent material behavior, and that he had these ideas about certain algorithms that we could actually, if we implement them in a certain way, you could link field observations with highly refined numerical models and really learn from these field observations. Yeah. So that actually appealed to me. One, because we have continued to develop new material constitutive models, classical plasticity type of models, for example.
Yes.
But the problem is we've always been having trouble being able to learn directly from the field. Now, of course, I had the background of the modeling from my PhD work as well as part of my practice, but also seeing how things work in the field. And I thought, you know what? First, I like this idea of something works like my brain. Of course, it's much more, at the time, primitive.
Yes.
But it's actually quite flexible, much more flexible, and it can adapt, it can change. So that's actually when my journey with AI started, is with working with these, and things developed since then.
Yes, I can say in 2025, we have come quite a long way between now and then.
Absolutely.
Lots of different versions over the years, I'm sure, too, of even just in the last few months, it's every newest version of the ChatGPTs and co-pilots and stuff.
The change we see in a month or two used to take us a decade before.
Yes, yeah, exactly. Continuing on awards in U of I, you want to talk about your Ralph Peck Award?
So after a number of, so that's many, many years later, I think around 2014, if I'm kind of correct. So that's when we went in earnest. I had a lot of collaborations with also Professor Rich Finnell at Northwestern. He's currently retired, whereby we try to now say, okay, so I have this tool for learning from field observation. There is this thing we call the observational method, right? Where we're supposed to, we have some initial designs. I'm greatly simplifying it.
Yeah.
But then as we go in construction observations, we see if things are going well or not. If not, we make adjustments and continues. Can we start looking at automating that process, enhancing it? Not fully, partially. I mean, eventually, yes, we'd love to.
Exactly,
but there is always going to be a role for us as engineers. That's where we bring in our own judgment, understanding. So we're kind of getting into this era. We were collecting data. For example, my research group was probably one of the first one in the US to use LiDAR to capture the geometry of excavations.
Yeah.
We then used webcams, image analysis to also track excavation progress. We had all these instruments that you can get data every half hour or whatever, frequency you want.
In 2014, all that was still,
new, but starting to come together.
Yeah.
And so we started putting this and we started demonstrating one excavation, another, one project after another through these various collaborations. Data I also got from Professor Whittle as well.
Awesome, yeah.
For an excavation on the MIT campus. And so thanks to colleagues at the Geo Institute, they saw that's good work.
Yes.
And as a result of that, there was a nice recognition of that. It was very fitting being the Ralph Peck Award medal and award, because of course, as you know, Ralph Peck, he founded the geotechnical program at Illinois, and I've had the privilege of also meeting with him a few times before he passed away. And I've actually, the first time I met Professor Peck, he was part of a peer review panel of the Muni Metro turnaround project.
Oh, I see. Okay, that comes full circle.
You see the connection.
Yeah.
And so it was really, really an amazing time. And again, at the time we had, young kids, etc. So thanks to my wife and the kids and their support, was able to deliver the lecture, and I'm very grateful for that recognition.
Yes. Yeah. I mean, the University of Illinois has a long history in the geotech and tunneling world with Peck.
Then later on, we had Professor Cording, Skip Hendren, and many other
Bill
luminaries.
Hansmeyer.
Bill Hansmeyer went to Illinois.
Yep.
Actually, I did work, by the way, at one point for Bill Hansmeyer when I was in industry. Yes, he had a project in Las Vegas called on the Nevada test site, and he asked me to do some numerical modeling. But I always say, whenever someone asks me, I say, okay, I got to see the site.
Exactly.
But you build the model. No, I got to see the site.
I need to get out.
I need to be out there. And when I would go commute back and forth to Las Vegas, to say, hard work.
Next, I wanted to talk about 2022. So we're jumping ahead a little bit for the National Academy of Engineering Award. So I was looking at the list of everyone who you were a part of that group. And there was individuals from Apple and Microsoft, the Department of Defense. There was someone from SpaceX, I think like maybe Elon Musk, maybe. There was a ton of, Salesforce, Pfizer, lots of different universities, another professor from the University of Illinois. You want to talk about that a little bit? That's quite an accomplishment.
So 2022 is when I was informed that I was elected to the National Academy of Engineering. It's again, I'm very, very grateful for my colleagues for nominating me for that. And there are a lot of accomplished engineers around the country, and the selection process is really, really tough. So it was really a gratifying moment for the recognition of the work that I have done, and including work related to underground structures as well.
Of course.
And so it was an experience. We went there and celebrated. There were several colleagues. It was actually the first time they had it in person after it was during the COVID, because they had COVID issues. So they were inducting 3 classes at the same time. So it was very large group of people, and it's. You sometimes wonder when you're there and you're listening all the accomplishments, say, well, are they sure? I was just checking. Really, that's I'm included in that group. So it's really, really a wonderful.
Awesome. Yes. Congratulations. And then recently, 2025, just won the Outstanding Educator for UCA.
That's right. Thank you so much. And I'm grateful for that. And, you cannot be an educator without 2 things: mentors.
Yes.
And mentees or students. And it's really the whole community. And the underground community is once you get to know it, the folks who work in tunneling and underground space, it's a special community.
Yes. What is the emerging technologies and stuff that you're thinking for, utilizing AI in the future of tunneling coming up? It's hard to predict the future, and we've come a long way since floppy disks and and our only field maps and having photos now. But what do you think's the kind of looking forward into the future?
So when I started my career, I recognized the importance of computer representation and modeling in our space. It's provide us ability to understand behavior, responses, consider design, prototype a design virtually instead of having to build it. So let's keep that as the general framework. But also we recognize the limitations of these tools. At the same time, we saw rapid changes in hardware. And also software. Software tools became more easy to work with, and hardware tools became faster and faster. So even our conventional, now we call conventional type of numerical modeling tools, we can run them faster, more efficiently. They've reached a level where they actually consider them standard. Now, at the same time, when I started my academic journey, I started working with AI, but it was pretty cumbersome because it was requiring a lot of time, simulation. The tools were not available, so we had to write everything from scratch. It is amazing where we are today. We're way beyond the simple neural networks. We're talking about generative AI, and more recent, and this is where for people more used to them would be like Gemini, ChatGPT, Grok, Copilot. So when it first kind of showed up at the scene, took the world by storm, right? But then as I started working with it, and we started playing with even the earliest version of these generative AI, we asked questions, even though we didn't provide information. It's something it took.
Yeah.
It didn't give bad answers. They weren't all correct.
Correct.
But also we actually asked some questions that usually correspond to what you would find on the PE exam. It managed to pass.
Oh, wow.
So then that kind of got us thinking. Okay. If you look at the tools that were available 2 years ago versus what we have now, still the same generative AI. They are far more powerful and more efficient. In just the span of 2 to 3 years, we're talking. So now we're seeing additions to this. In addition to these generative AIs, we're seeing tools to make them accessible to us.
Yes.
You hear about RAGs and agents, and you hear the term agentic AI. What it is that it allows, these tools allow you to bring in your domain knowledge, domain expertise into that, bringing the power of generative AI to this specific knowledge so that it can give you information guided by that specific knowledge. Now that was, so decided, you know what? I wanted to develop a virtual TA.
Yeah.
Well, using my class notes and information. It took us about 2 months over last summer to generate it for a class I was teaching on earthquake engineering. And we had students use it, etc. Typical question. When is the exam? It gives you the answer. When is that? Students don't need to know where the syllabus is, etc.
Exactly.
Which even though you put it out, reading it becomes an optional
Correct.
thing.
Yeah.
But then I decided this spring I was teaching another course, computational geomechanics, numerical modeling, where we also brought in AI.
Yeah.
It took me 1 hour to generate the same thing. So 2 weeks versus 1 hour. I'm sorry, 2 months versus 1 hour. I've even tried to, I have continued over the years my involvement with industry, plus also nowadays you find lots of project documents online. I said, you know what? Let me see if I bring in together a bunch of project documents within a sort of a protected environment and start using these tools. It was amazing how it is able to integrate the information. So where are we going with this? If you remember, we were just talking earlier today about when we go and do our observations, I have the visual inspection, the numerical data, and we were always struggling. How do I combine this heterogeneous data set? Well, the new AI agents, generative AI tools can combine photos, videos, audio, text, digital data, project information, ingest it, and help you evaluate, synthesize, etc. So the dream we were having of trying to pull these together, it's kind of we're realizing it nowadays.
Yeah, it's now.
It is today. There's so much interest. There's so much economic incentive, of course, for that.
Exactly.
And that is going to be very helpful for us as an industry. Why? Any project you get involved with, usually you have thousands of pages of documents.
Yes.
And when you're trying to find something, you can do a PDF and do a search, but even that doesn't always work, right?
Nope.
Now we're able to put these there and quickly ask questions, and they help us, assist us in our decisions. But we should never forget our role as engineers.
Yes, we still want to be able to, have jobs. We don't want to use it as a replacement. And again, we're as a geologist, engineers, geotechs, civils, everyone, we want to make sure we're using our own knowledge and things that it doesn't understand or picks up. And it's a great tool and use, but
Absolutely. And what is seemed impossible just a few years back. So we have this collaborative research project with the Los Angeles Metro, and they shared with us TBM data. So TBM data, even for a few miles of a single tunnel, you're collecting billions of data points in terms of the TBM measurements, and then millions of, say, points on the surface measuring deformations,
cutting rates, timing, environmental hazard, the gases or anything that could be there. Yeah.
Have you tried putting that in an Excel spreadsheet? You can't. We found that we're able to use these advanced AI tools to allow us to benefit from this incredibly valuable data. Because after all, the data is not only about the performance of the machine, it's the reaction of the machine to the ground.
Correct.
Well, this means within it has a lot of knowledge.
Exactly.
How do we extract that knowledge? How we connect? We've made some presentations. We have some papers talking about that, but the real meat is coming up in the next few months. So that's where we are. We're now going to be able to work more closely between design engineers, field engineers, contractors, all this massive amount of data now, these amazing machines that are collecting, we can actually benefit it to improve the project delivery.
Exactly. Yeah. The future is bright and the future is right around the corner for us.
It's exciting.
Yeah. Well, appreciate your time, Professor Hashash, and thank you very much for getting our first inaugural episode in, and thank you very much for your time.
Well, thank you so much, Luke. Appreciate it.
You've been listening to Tunneling Today with UCA, where the stories are deep and the insights are deeper. Thank you for joining us. Don't forget to subscribe to our podcast so you never miss a beat from the world of underground construction.